Hello students, welcome to Nagesh Karasgi Orchid School channel. Myself Priya teacher. Today I am going to teach you science subject for class 7. So children, in our last session we discussed about electronic symbol and also we discussed that heating effect of electric current. So it means we started lesson number 14, electric current and its effect. So can you tell me which are the electronic component? Yes, correct. So electric cell, battery, then wires, all these are electronic components or electric components. And can you tell me some names of electric appliances which are showing heating effect of electric current? Yes, correct. So some toys are there, some transistors are there, batteries, torch, not battery, torch, and also you can say the iron, electric iron. So these are some examples of heating effect of electric current. So let us move to our next point of this lesson, lesson number 14, electric current and its effects. So next point, electric fuse. So what is mean by electric fuse? So electric fuse is a safety device used in electrical circuits which protects the electrical circuits and appliances and prevents fires. So what is mean by electric fuse? So whenever there is a large amount of electric current is going to flow through the wires, at that time some metallic wires cannot tolerate this large amount of electric current. So that is why what happens here, so these wires are going to burn because of large amount of electric current. So it is very harmful if suppose that wire is going to burn. So many of the times you can see whenever there is high voltage, we not say like a large amount of electric current, but we say at our home that when there is a high voltage, if electricity is not there and after some time it comes back electricity, that time what happens, that because of high voltage sometimes we see or we saw that bulbs are going to, that wires from the bulbs are going to burn, okay. Or sometimes what happens, fuse at our home it is going to be off and also that electric current is going to be off like this. So this electric fuse, so when there is a high voltage, what happens, that fuse is there only, that fuse is going to save us from this high voltage, or you can say whenever there is a large amount of electric current. So electric fuse is a safety device used in electrical circuits which protects the electrical circuits and appliances and prevents fires. So suppose not bulb is there, if any machinery is there, that computer, TV, fridge, oven, washing machine like this, and this will happen there, that high voltage will is responsible for the fire is there. So it will, fuse will protect us from these fires. It will, what it will do, so it will not allow to happen these things, okay. So it is going to save us from all these things. So electrical fuse is used in an electrical circuits in buildings. So whenever there are buildings it means it is having, buildings is having flats, so many flats. So in here Solapur you can see there are the 7 floors, 6 floors or 4 floors are there in building, in a building, and each floor is having 4 flats, 5, 6 flats like this. But in Mumbai, Pune you can see these buildings are having many floors, so like 25, okay, 20, 30 like this. So flats are also there. So these buildings are very huge or very big. So that is why they need to control whatever electric current is passing throughout these buildings, okay, or from their homes, or there are so many electrical appliances which are used by these people who are living there in buildings. So they are going to use this, and suppose this system is not there. Which system is not there? Electric fuse is not there. So it will not possible to that electric appliances to control that electric current which is going to flow from this electrical appliances. So that is why electric fuse is used to control this electric current in that electrical circuits which are there in a buildings, okay. So it is for our safety. So electric fuse has a wire which melts quickly. So how this electric fuse is going to control this? So that electric fuse is having a wire which melts quickly and break. So electric fuse has a wire which melts quickly and break when large electric current flows through it. So here you can see fuse used in a building. So which type of fuse are used here? You can see this is the picture of electric fuse, and here you can see this is a fuse wire, okay. So this is a fuse wire, and whenever there is a high voltage, that time what happens, this wire is going to break like this. So because of this breaking of this wire, that flow is not going to pass through the other appliances which are used in this building or in the people's house or in a electric appliances. So that is not going to flow from that electric appliances, okay. So that electric current is not going to reach there. So why? Because this fuse is going to disconnect that current, okay, by breaking this wire. So this wire is only for these purposes here, okay. So electric fuse has a wire which melts. When there is a high electric current, this wire is going to break, and this is going to disconnect the electric flow in between these home appliances, okay, or whatever electric current is used in a buildings or in houses, okay. So like this electric fuse is working here. Then next point is a magnetic effect of electric current. So as we know that heating effect of electric current is there, also there is a magnetic effect of electric current. So I think you are wondering that how it is possible magnetic effect, okay. So let us see, children, when electric current flows through a wire, it behaves like a magnet. So what happens here? When electric current flows through a wire, it behaves like a magnet, and this is called magnetic effect of electric current. So in your previous class you learned a activity. So what activity is there? So you have to take a comb and you have to rub it on any woolen cloth or on any silk cloth and also on a cotton cloth, and then you have to take this comb to the papers, okay, whatever teared paper is there, near to this teared paper you have to take this comb, okay, and what you will see, that papers are going to cut, whatever teared paper is there, that is going to touch to that comb. So like this, here also what happens, when electric current flows through a wire, it behaves like a magnet. So that wire is going to behave like a magnet and it is going to attract something. So what it is going to attract? So this is called a magnetic effect of a electric current. So what is going to attract here? We will see. So through this activity. So we will read this activity first, then I will explain you. So take the cardboard tray from a matchbox. So you have to take a cardboard tray from the matchbox, then wind an electric wire a few times around the cardboard tray. So, here you can see you have to wind this electric wire around the cardboard, okay, some few times, not only once. So, more than once you have to around, okay, tie this wire around that matchbox or that cardboard tray, sorry. Then place a small compass needle inside it. So, you have to take a compass needle and you have to keep that compass needle inside that cardboard tray, and the whatever wire is tied there, wind there. Then connect the free ends of the wire. Then you have to connect these ends of this wire. So, where you have to connect this? To an electric cell through a switch. So, you should have to take a switch, and here you can see this is a symbol of switch, this is a symbol of a cell, and what is this symbol? Yes, correct. So, this is a symbol of battery, okay. Then when the switch is on, the compass needle deflects. So, when the switch is off, the compass needle comes back to its original position. So, this shows that when electric current flows through a wire, it behaves like a magnet. So, when we connected this both ends of this wire to a electric cell and also we attach a switch there, then what happens? So, when the switch is on, the compass needle deflects. So, this needle which is there in a compass, that is going to deflect, okay, and when a switch is off, the compass needle comes back to the original position. So, this is a proof of that electric current is, when that electric current is going to flow this wire, that wire is going to behave like a magnet. So, this activity is given here. So, how this magnetic effect is used in such type of electric appliances. So, let us see. Next one, electromagnet. So, there are some electromagnets are used which are based on this type of magnetic effect of electric current. So, when electric current is passed through a coil of insulated wire. So, when there is a electric current passed through a coil of a insulated wire wound around a piece of iron, it becomes a magnet. Such a magnet is called an electromagnet. So, now see what is given here. You need a coil of a insulated wire. So, in this image or in this figure you can see this is nothing but a coil of insulated wire. So, in our previous session I told you insulated wire, it means it is covered with insulators, okay. So, this type of wire you have to take and then you have to wound this wire around a piece of iron. So, iron nail is here, you can see a big iron nail is there. You have to wind this wire around this nail, then it becomes a magnet. But how it is going to become a magnet? So, let us read this activity. What we have to do, then it is going to become a magnet, and this type of magnet, it is called as an electromagnet. So, wind a piece of insulated wire around the iron nail like this in the form of a coil. So, whatever that wire is there, you have to wind this wire around this nail in the form of coil. So, you know what is meant by coil. So, whatever structure you can see here, this is showing a coiled structure around the nail. Then connect the free ends of the wire to an electric cell through a switch. Then what you have to do? You have to connect these free ends. So, whatever free ends are there, you will get two free ends. So, you have to connect these two free ends to an electric cell through a switch. So, here is a switch. Okay. So, to this switch you have to connect one end, then another end you have to place some pins near the nail, and another end you have to connect with this switch, and also there will be a battery here. Okay. So, here you can see a battery. Then place some nails near the nail. You have to place some pins here near to the nail, and then when electric current is passed, so you make here a circuit. In this circuit you are having switch, then you are having wire, then also battery is there, and then you have to switch on and switch off. Then first you will switch on that electric current to pass, to allow the electric current, and the iron nails becomes a magnet and attracts the pin. So, when you will switch on, what will happen, that iron nail, it will becomes a magnet, and that is going to attract that pins. And when electric current is switched off, the nails loses its magnetism. So, when you will switch off, then you will see that pins are going to be off, then because of no magnetism is there in this nail. So, it means that nail is going to lose that magnetism. So, this activity is given here. So, when you will perform this activity, so do not perform this activity at your home, it will be dangerous. When you will come home, come to school, that time I will show you. So, this is called as a electromagnet. What is called as a electromagnet? When this nail is going to be changed as a or behave as a magnet, that time this nail is called as a electromagnet. So, why this happens? Because of electric current which is going to flow through this wire. Because of that, this nail is going to behave like a magnet. So, that is called as a electromagnet. So, hope you understood this concept, which is a electromagnet. Then we will go to the next concept, which is electric bell. So, electric bell. So, this is one more electric appliances which is used many of the times in offices, schools, colleges. Okay. So, the electric bell has a coil of a wire wound around a piece of iron. So, what this electric bell exactly is having, or what type of structure it is having. So, how it is made up of, which from which substances. So, when you will see electric bell, it will look like this. Okay. Then here it is given the structure or the figure, what exactly is there inside that electric bell, or what type of circuit is there. So, first we will see the electric bell has a coil of wire wound around a piece of iron which acts like an electromagnet. So, what is there in a electric bell? So, in electric bell there is a coil of a wire. What is there? There is a coil of a wire which is wound around a piece of iron. So, which is wound around a piece of iron, and that iron is going to behave like a electromagnet. So, an iron strip with a hammer is kept close to the electromagnet. So, that iron strip with a hammer is kept close to the electromagnet. So, that iron is having a hammer, okay, and that hammer is kept close to the electromagnet. So, when that iron is going to change into a magnet, so there should be a hammer which is going to play that bell. That is why it is given, an iron strip with a hammer is kept close to the electromagnet. magnet. Then there is a contact screw near the iron strip. So there is a contact screw near to the iron strip. Then when the iron strip is in contact with the screw, current flows through the coil and becomes an electromagnet. So what happens here? First you can see this figure, first one. Okay, this is nothing but a bale. Okay, then there you can see a striker. So striker, it means this is a in between, this is shown that a contact. So what contact is shown here? So there is a contact screw near the iron strip. So this is a contact screw near to the iron strip. So this is nothing but the iron strip is here. This is yellow colored structure which is having a hammer, that is the iron strip, and that iron strip with hammer, it is called as a striker. So in this picture also you can see this is the iron strip and this is having a hammer. This is nothing but a bale. So this hammer with iron strip, it is called as a striker. Then this is a spring. Spring is placed here for the movement of that striker. Okay. After that, when there is a electromagnet is produced, that time, or magnetism is produced because of electric current, that time whatever movement will occur there, happen there, for this movement there it is given a spring, and here is a switch, and here you can see a cell. This is a structure of nothing but a cell. So this is a positive, red one is a positive terminal, blue one is a negative terminal. Okay. So see, then there is a contact screw near the iron strip. So here you can see the iron strip, and this is a screw. Okay. This one contact screw is here. Then when the current flows through the coil and becomes an electromagnet, it pulls the iron strip, and the hammer at the end of the strip strikes the gong of the bell and produces sound. So read with me carefully what exactly happens there. So there is a contact screw near the iron strip. So an iron strip with hammer is kept close to the electromagnet. So here you can see the electromagnet, then iron strip, and this current is going to flow through the coil. So here you can see the coil is there which is wound around the iron strip. Okay, and that iron strip is connected with the cell and switch, and this is a screw which is having a hammer here, and this is nothing but a bell is there, gong of the bell. So when this current is going to flow through this coil, so when current is going to flow through this wire, what happen? That is going to behave like a electromagnet, and because of that this is going to move. So this current will come to this screw. Okay, that screw is going to deflect, and this screw, because of that deflection, that screw is going to show some movement, and after this movement it is going to connect with this iron strip. Okay, with this screw which is there to the iron strip, and then it pulls the iron strip, and the hammer at the end of the strip strikes the gong of the bell. So whatever there is a hammer, this is a hammer. So this hammer is going to gong on this bell. Okay, and it is going to produce the sound. So when the electromagnet pulls the iron strip, it also breaks the circuit, and the iron strip comes back to the original position. So and the process repeats, and the bell rings. Okay. So what happens here? When the electromagnet pulls the iron strip, it also breaks the circuit and the ion strip becomes back to the original position and connect the process, and the process repeats and the bell rings. So, here it is the function, you can see functioning of the electric bell. So, we will see a video which explains you how exactly this electric bell works.
Electric bell. Magnet is used in an electric bell. An electric bell has an iron hammer, structures of metal around which the wire is wound. When we press the button of an electric bell, the current begins to flow through the electric wire, turning metal structures into temporary magnets. The magnet attracts the iron hammer. The hammer strikes the metal bell to produce a sound. At this stage, the connection between the screw and the hammer is broken and the electric current stops. The magnetism of the coil is lost and the hammer goes back to its original position. The electrical circuit is completed by joining of the screw and the hammer, and the bell rings. The process is repeated and the bell rings intermittently.
So, children, hope you understood how that electric bell works properly. So, this is a very short video. So, I am going to show you one more time. So, see this time very carefully, okay? And also you can make this type of bell at your home.
Electric bell. Magnet is used in an electric bell.
See, here you can see this is the bell, and here is a switch, this is battery, and these are the cells. And here you can see this is a hammer which is made up of a metal, and here it is a screw, it is attached with this hammer, and this is a gong of a bell. And what happens when this current is going to pass through these wires around this iron strips, then it is going to become a electromagnet, and because of that it is behave like an electromagnet. So, this metallic hammer is going to going to attract towards these iron strips, and when it attracted towards these electromagnets, this hammer is going to gong on this bell. So, when you will switch on, it will going to gong on this bell, and when you are going to switch off, this is not going to gong on this bell. So see this video one more time.
An electric bell has an iron hammer, structures of metal around which the wire is wound. When we press the button of an electric bell, the current begins to flow through the electric wire, turning metal structures into temporary magnets. The magnet attracts the iron hammer. The hammer strikes the metal bell to produce a sound. At this stage, the connection between the screw and the hammer is broken and the electric current stops. The magnetism of the coil is lost and the hammer goes back to its original position. The electrical circuit is completed by joining of the screw and the hammer, and the bell rings. The process is repeated and the bell rings intermittently.
Okay, so hope you understood what we discussed in our today's session. So we learned about what we learned today. So what is mean by the magnetic effect of electric current and how it is applied in our day to day lives. So, also we learned that how that on the basis of magnetic effect of electric current, we that electric bell is going to work. So, hope you understood all these concepts. In our next session, we will discuss some more interesting concepts. Okay. So, today we will stop here. Thank you, children.